as told, I work in Italy for the ITAS RTA groups. RTA stands for Real-Time Application. Is the group which mainly deals with topics like embedded software, AUTOSAR, and safety. Is AUTOSAR suitable for off-highway market? In my opinion, since AUTOSAR is a general standard for software development in automotive, is suitable for different, let's say, market. In particular, I found two reasons why it is particularly suitable for the off-highway. One is this one, because it's more common that in the off-highway market that the OEM holds the software development process. So for OEM on this particular market is even a more powerful tool rather than in the passenger market, for example, because they can use it as a real development tool for the entire vehicle software development, rather than a simple methodology to exchange the artifact with the supplier of the ECUs. So it's probably more powerful in this sector. And the other one is probably a more technical and vehicle architectural motivation. Is more common in the off-highway to have similar instances of ECU with some different hardware population reused in vehicle architecture, and so it's probably more common the use case to move software component between ECUs. So these two reasons, I think they are other good reason because to justify the usage of AUTOSAR on this specific market. This slide shows our offer in terms of tooling on the AUTOSAR across the entire AUTOSAR process. We can start from this side with our authoring tools. We have an authoring tool for the software component description called ISOLARray, Integrated Solution for AUTOSAR. And we also have a plugin of this tool, which is more targeted for the ECU description, so for the basic software configuration, called BCT, Basic Software Configuration Tool. On the actual software, functional development, we propose our model-based design tool, ASCET, but the entire toolchain is completely interoperable with other third-party tools like MATLAB, Simulink, or unwritten code. There is no limitation. On the basic software, so infrastructural software generation, we have 3 generators, a generator for the RT, one for the OS, and another one for the BSW, which is one of the most recent products, called respectively RTA RT, RTA OS, RTA Basic Software. The output of this process is the generation of a set of C files that can be run by our virtual validation tool, ISOLARiv, to virtually run the ECU. This tool basically generates some virtual part and allow to make some virtual validation. So we can develop software components without have to worry about in which ECU they will run in the future, and we can move software components between ECU. This is a very important goal. As a collateral of this main result, we have a high modularity and stratification of software, which allows to replace also part of the infrastructural software with less impact than in the past. And finally, also the standardization, the ugly standardization of the software reduce the number of bugs, so produce a more reliable final product. This is a project we run with agricultural OEM, is CNH in Modena, and the project was a dashboard for agricultural application. It was a tractor, if I remember correctly. We provided the whole tool chain with exception of the basic software, because they choose to use Komasso, which is the open source implementation of the AUTOSAR basic software. Since they are part of the consortium, they can use it. So we provide the authoring tool, the OS, the RTE, and across along with that also an engineering services that was basically an integration activity. So we provided an architect figure and some consultant to make the integration of the various parts of the software. There was software components coming from CNH itself, the graphical part coming from another supplier, some low-level drivers coming from the hardware supplier. So it was a good project with a good result that showed that the capability to provide tools and also some integration services and coaching activity.
Do you see a trend to actually ease this process, going away from code generation for a certain target, more or less embedded? Even if you isolate this and try to make the process easier, do you see a trend that this is being replaced by something that is more web-based, easier to generate apps that could run anywhere without even thinking about code generation?
Stalled for the classic embedded, no. For the adaptive platform, which is more service oriented, more oriented to that kind of architecture, maybe yes, but I don't know, because it's a really recent development of the standard.
You spoke of Eisler E. Thank you for that. I'm the product manager of that product at ITAS. In the next version coming out in May, we will have introduced a version that will support not only the classic platform, but the adaptive also, so that you can import descriptions like this in a comprehensive way. This does not necessarily say that you can use Eisler E to configure adaptive platforms already, but you have a platform by which you can look at artifacts from both worlds in one tool. The other part of your question, as far as I understood it, was how to get these two worlds together. I would not say I have a complete overview here, but one element could be the communication between both worlds. That can happen via some IP or service-oriented communication, as an example. Another, looking at software artifacts, could be that you use a common platform by means of a hypervisor, lightweight hypervisor, sitting on top of a common hardware architecture that allows both parts of the software to integrate into one ECU, into one piece of hardware on basis of such a hypervisor.
Wunderbar. Also
Fantastic. Today we're going to talk about a new way of programming software or making software available on ECUs.
The driver simply uses a tablet to log into the Bosch feature store. By identifying himself with his fingerprint, a safe connection is established. In the feature store, the driver can choose from a range of applications. While Bosch is offering the Bosch feature store as a platform, the applications can be developed by various parties, a Bosch engineer, a customer, or even a third-party engineer. The driver selects a suitable feature for his use case. In this case, he has chosen one that calibrates the drive, steering, and brakes of the truck. The feature is installed in the truck via the Cloud Technology Software over the Air, or SOTA for short, and the tablet is updated with the new feature. After selecting the application on the tablet, it is activated via the cloud and the parameters of the truck are changed to the off-road mode.
Wir versuchen Technologien und nachladbar.
We're trying to provide features in a framework which are found in component ECUs or domain ECUs.
Den Weg, den wir jetzt gehen wollen,
we would now like to choose a different path, actually two paths, best of two worlds. We want a stable development process for firmware. So putting functions on the market, putting functions into the vehicle. We're going to do this based on the conventional development methods and processes. But in addition to this, by means of hypervisor technology and other extensions that we are currently developing, to enable an encapsulated function download with development in the cloud. So the basic functions of the vehicle remain in some kind of basic software, but any other additions, like for example, if I have an implement or something over the life cycle of the vehicle, new functions, new sensors, new protocols, all this would then be done via an incremental update.
Diese Möglichkeit hier zu eröffnen,
In order to enable this, we need a different kind of development architecture and development approach. And we've developed a technology which runs in the cloud, and it allows the encapsulation of the development process. So the programmer receives a framework. Within this framework, he can move freely, he can develop a function, and he can also configure the ECU without having access to any IP-protected files.
Ich mag Ihnen an der Folie in ein paar wenigen Worten
I would like to explain to you
ein solches Feature, eine solche
how a developer can develop such a feature, such an app,
wird sich
based on this framework, on this platform.
welches Target möchte er gehen.
Now, first of all, we will think of the target, which software he will find, which infrastructure he'll find there. And then he will use a tool which we call EasyConfig. It will look at the interfaces and the basic software and what it looks like in this framework. And for his application, be it I/O, or communication, the features will be provided. The corresponding interfaces will be selected, and he will then get support in order to program the application software. Support means that he gets a set of interfaces based on C signal header information against which he can do his programming. In the next step, some compilation will take place. The basic software plus the application software layer. All this is running in the cloud. Next step, simulation, the simulation platform, so that you can simulate what you have programmed online. And another interesting topic, OBD and ISO. We use this process step so that before we put this in the vehicle, we have actually validated it correspondingly. And as Bosch, we can offer the corresponding services, but it doesn't necessarily have to be Bosch. And once you've gone through all these process steps, the developer will provide the feature through the feature store, so it's like an app store. And such a feature, well, it would, for an app costs €1, but this kind of feature will probably cost a little more. And just as Mr. Münzmeier said, it can be downloaded via some, any terminal device such as a tablet. We will get to the status of an A-sample by the end of the year.
Der Knackpunkt, und da sind wir schon relativ weit fortgeschritten, nicht für Sommer nächsten Jahres, wahrscheinlich erst ein Jahr später, uns Gedanken zu machen, wie kann ich Wirkketten modellieren.
So the question becomes, how can I validate cause and effect chains? How can I have an input signal and then later execute it so that it remains secure, safe, and meaningful and beneficial? Of course, that needs to be guaranteed. We're developing this at this moment, and I'm sure that this will feature on the agenda of next ITAS Connection.
Ich möchte Ihnen da das Bremssystem.
I should like to introduce to you the APIS 2002, which is our APIS platform for these kind of brakes, and talk a little bit about the success factors behind it.
Das Ganze wird jetzt aus der Sicht
The whole thing, from the point of view of the project engineer, is now put into a certain tooling environment. It's dealt with this integrated tool chain here, and all the deliverables that he or she needs for his or her process can be taken from this integrated tool chain or can be generated from it. So We've done this particularly for our brake control systems in-house. So, software parts are generated, emergency braking kits are generated, module tests are generated for application blocks, hardware and software test stands can be dealt with, parameter sets can be generated for manufacturing. The service tool needs to be designed in a project-specific way because the particular signals of the customers need to come up there, and the customer wants to do maintenance on the system with it. And last but not least, the application logic for the certain project, the particular signal situation and the functions in the project need also to be designed. And we are doing this within the ASCET ETAS tool, and I'll talk about this more in detail in a minute.
Was haben wir mitgenommen?
What is it that we've learned? What are our lessons learned? The system solutions for customer-specific projects should be as flexible as possible and should have a modularized system architecture so that we can respond to the particular specialty features. Standardization in a global network is possible. However, the solution must cover the entire bandwidth of the market, and it needs to be a perfect fit so that the users will actually accept it. The guidelines, directives, and coordinating reviews will support everything, but they are absolutely not sufficient. What's important is that the standard matches becomes the project engineer's very own interest. If the project engineer actually wants to have this standard, then he will accept it if we offer it to him. And then we have a combination of customized modules and commercial off-the-shelf or COTS products, and own developments, our own development. This combination is going to win the game. So together with the support of other actions, we have been able to reduce by 40% roughly the project engineering efforts as compared to other customer projects.
Wir haben jetzt hier eine Lösung für diesen.
Now we've got a solution for metro here, which, when it comes to the market segment, is a little more straightforward because metro trains have certain similarities, even if they run in different urban areas or different countries. The boundary condition may be slightly different, but they are a lot more similar than rail vehicles in general. At the moment, we are developing new, more generalized braking platforms, which are meant to realize the same principle again. So we want to have a plug-and-play system on the device level and certain services in the system, and also a corresponding tool chain, which can actually cope with the degrees of freedoms that the systems have and have to have. So for the different locations of our organization, we have to do this, because if we don't do it, the tool knowledge doesn't actually reach the different locations and the different project engineers.
Bei uns ist die Besonderheit, dass also
in our case, what's particular is that very often we don't have the system requirements at the beginning. So only we have a very coarse explanation at the beginning of what the brake system is meant to be able to do. And then during the further course of the project, we can do the technical clarification more in detail with the customer in order to find out how the brake system should actually cooperate and interact with the car. Our consultation space is not that great, so it's very good that, if you know right from the beginning what your systems can do and what they cannot do, and this can be discussed a lot better with your customers as compared to if you say, okay, let's take all the requirements in and then I'll look at how I can cope with them. So what consultation space there is, we need to make best use of that.